Episode 11. First, I want to show how can a circle, this is a circle, how can this circle be transformed into an ellipse, and this transformation is called affine transformation. I will show you in a practical sense how this transformation happens, how this circle is transformed into an ellipse. Take a thick book, and the book like this, and draw a circle on the side of the book like this one. And now I can transform this circle into an ellipse. This is how the circle is transformed into ellipse. This is the transformation into ellipse, and I can show you practically what happened during this transformation. This is a blue line on the circle. This blue line is transformed into this blue line into the in the ellipse. If this blue line is dB distance from the origin, then the transformed blue line on the ellipse will be k times dB. K is a constant multiplier. It has the same value for this transformation. Similarly, this green line, which is a distance dg, this is the dg distance from the origin, it is transformed into this green line, which is k times dg. And this red line is transformed into this red line, and the red line on the circle is RD from the origin, and its transformation is k times dr from the origin. This k is actually the radius of this circle, radial distance, is transformed into the semi-major axis of the ellipse. So this distance of the radius from O to this point is transformed on the ellipse from O to this point. And similarly, so we can define k equal to semi-major axis divided by semi-minor axis of the ellipse, which is also the radial distance. Therefore, the area of the ellipse will becomes k times the area of the circle. So, area of this ellipse is k times the area of the circle. Okay, the same is true for a sphere. Whatever I have explained here is true for the sphere, and the sphere can be transformed into an ellipsoid. So, in the previous examples in our episode 10, we have this is a sphere, and it has one exposed surface which was pi AB. Suppose this surface, which is given by the shaded lines, is given by this black line here, or this black line on the circle here, this one, and we transform this surface, and this black line represent this exposed surface on the sphere. Okay, and the value of this surface is pi AB, which is in the previous example. So, this line is transformed into this black line, this here on the ellipse, which represent the surface area. And one thing should be remembered, that this line is a constant, is the same, has the same value as the black line here. Even all these blue, this blue line and this blue lines are of the same length. This red line is the same length as this red line. So this surface area, if this line is representing surface area, exposed surface area, then this surface area will be transformed up here, but its value remains the constant. So now what happens to the this? Let's go back to the example we already have in our previous episode. What happens to this example 2 if we transform this sphere into an ellipsoid? The only thing happens that each space, each volume is multiplied by a constant factor. So the empty volume will become, just 1 minute, let me put the pen. The empty volume will become k times this. So in a transformed version, it will be the k times this one. So here it will be a k, which is a constant multiplier. Same is the volume of the oil in the transformed ellipsoid. It will be k times the volume of the oil. So it's just so easy. You just have to multiply with the k, which is the semi-major axis divided by semi-minor axis, and the volume of the water in the transformed ellipsoid will be k times the other integral. So here it will be k times. So it's only the factor k, which when we introduce, which will transform the sphere into an ellipsoid. So finally we have this one. So the section B of this section B of the sphere, which is this one and this one, which is given by the B2, is transformed into the k times B2, which is this section between this one and this one. So that's why this dashed lines shows the transformed volume, and this is the volume of the sphere. Finally, I would just say the sectional volume of ellipsoid is equal to k times the sectional volume of sphere. Any section of the sphere or the ellipse can, any section of the ellipsoid can be transformed into spherical volume. So the only factor in between is the k. When the k is greater than 1, the ellipsoid will be prolate. If the k is equal to 1, is the sphere, and if the k is less than 1, the spheroid will be oblate. Okay, thank you.